All right, Chem students, today we're going to continue our stoichiometry unit. You need your stoichiometry notes, a periodic table, and something to write with. Okay, this is the most important thing for stoichiometry calculations. There are three basic steps to a stoic problem. Number one, identify the given and convert it to moles. Use one of the three mole conversion factors that you already know. If it is already in moles, you don't need step one. Okay, so that's the thing. Identify the given and convert it to moles. If it's already in moles, you don't have to do it. Now, step two, you're always going to do step two. Identify the unknown and do a mole-to-mole ratio between the given and the unknown using the coefficients from the balanced equation. This is the most important step. So if you need to balance your equation first, do that first, because you're definitely going to need it for a stoichiometry calculation. You can never ever skip this step. Now, step three, convert the unknown to the unit specified in the problem. If you are asked to solve for moles, you don't need this step. Step one, identify the given, convert it to moles if you need to. Step two, identify the unknown and do a mole-to-mole ratio between the given information and the unknown that they're asking for. And step three, convert that unknown to the unit they asked for. If they just wanted moles, you're already finished. Now, let's try this. We have aluminum oxide breaking down to give us aluminum and oxygen. First thing we need to do is balance it. So we have 2 moles of aluminum oxide decomposing to give us 4 moles of aluminum, 3 moles of oxygen. Now, how many moles of aluminum could be produced from 13 moles of aluminum oxide? All right, step one is to look at our given. 13 moles of aluminum oxide. Now, is this in moles? Yes, it is. So we don't need step one. We don't have to convert it to moles because it's already there. Step two is our mole-to-mole ratio. We do need that. So our mole-to-mole ratio here, we started with aluminum oxide. We need aluminum oxide to be on the bottom. There is a 2 in front of aluminum oxide, so that's where this 2 comes from. Now we're converting this because they asked for moles of aluminum, so 4 moles of aluminum goes on top. That's all they asked for, so we don't need step 3. So we can just do the math. 13 times 4 divided by 2, our answer would be 26 moles of aluminum. Now for number 2, y'all give it a try. Okay, let's see how you did. They wanted to know how many moles of aluminum oxide would be required to produce 5 moles of aluminum. So we have 5 moles of aluminum as our given, and we wanted to see how many moles of aluminum oxide that would have taken to make happen. So moles of aluminum here, that means we're already in moles. We don't have to do step 1. We go straight to the mole-to-mole ratio. 4 moles of aluminum will be on bottom. 2 moles of aluminum oxide, which is what they're asking about here, goes on top. Then we just do the math. 5 times 2 divided by 4. We round that to 3 for sig figs. Okay, our next example is a mole to particle problem. How many molecules of aluminum oxide are needed to produce 1.85 moles of aluminum? So our given is right here, 1.85 moles of aluminum. Now step 1 is convert the given into moles. That's already been done for us, so we get to skip step 1. We go to step 2, our mole-to-mole ratio. So we're going to convert moles of aluminum to moles of aluminum oxide. So moles of aluminum goes on bottom because that's what we started with. Moles of aluminum oxide on top. We fill in the 2 from here and the 4 goes here. Step 2 is complete. Now, they did ask for molecules of aluminum oxide, so step 3 is necessary. We're going to convert from moles of aluminum oxide to molecules. That means we need our mole to molecule conversion factor, which looks like this. And the only thing left to do is the math. So 1.85 times 2 times 6.02 times 10 to the 23rd, then divide by 4. That gives us 5.57 times 10 to the 23rd molecules of aluminum oxide. Now, pause the video and take a minute to do problem 4. Okay, problem 4 said if 1.20 times 10 to the 21st atoms of aluminum are made, how many moles of oxygen are also produced? We're starting here with our given, 1.2 times 10 to the 21 atoms of aluminum. We do have to convert to moles this time because they gave us atoms. So we use the atoms to mole conversion factor. Now we convert moles of aluminum to moles of oxygen. So we need our mole to mole ratio. Remember, you'll always need this step every single time. We do the math, 1.2 times 10 to the 21 times 3 divided by 6.02 times 10 to the 23rd and then divided by 4. You will get 0.00150 moles of oxygen. Okay, next example is a mole to mass problem. How many grams of oxygen would be produced from 22 moles of aluminum oxide? The 22 moles of aluminum oxide is our given. It's already in moles. We don't have to convert anything, so we don't need step 1. We're going to go straight to step 2. We need to convert moles of aluminum oxide to moles of oxygen. So aluminum oxide is on bottom because that's what I started with. 2 from our balanced equation goes here. The 3 in front of oxygen goes here. So step 2 is complete. We did the mole to mole ratio. Now they asked for grams of oxygen though, so step 3 is necessary. We're going to convert moles of oxygen to grams of oxygen. So I looked up on my periodic table. Oxygen, there's 2 of them, so 15.999 times 2 gives me 31.998. Multiply across the top, divide what's on the bottom. Our answer will be 1055.9. We had 2 sig figs when we started, so we got around to 2 sig figs though. So our final answer will be 1100 grams of oxygen. Now, take a minute and do problem 6. Okay, let's see how you did. So they gave us 890 grams of aluminum oxide as our starting point. So that is our given. That is not in moles, so we do need step 1, convert it to moles. So we need the molar mass for aluminum oxide down here on the bottom with 1 mole on top. So step 1 is done. Step 2, we need to convert moles of aluminum oxide to moles of aluminum. We will always need step 2. So we plug in the numbers from our balanced equation. 2 moles of aluminum oxide on bottom, 4 moles of aluminum on top. And fortunately, that's all they wanted to know was moles of aluminum, so we do not need step 3. I'm going to multiply my numbers across the top, divide by what's on the bottom. My answer will be 17 moles of aluminum. Okay, our next problem is a mole to volume problem. We have 12.4 liters of oxygen gas at STP that's produced when how many moles of aluminum oxide decomposed? So our given is 12.4 liters of oxygen. That's our starting point. Now step 1, convert to moles. It's in liters, so we do need step 1 this time. So we're going to do a moles to liter conversion. 22.4 liters in 1 mole. Liters was here, so liters needed to be on the bottom this time. That's step 1. Step 2, convert from moles of oxygen to moles of aluminum oxide. Put the numbers from the balanced equation where they go, so moles of oxygen, 2 moles of aluminum oxide. That's all they asked for, so we don't need step 3. We can do the math now. So 12.4 times 1 times 2, divide by the stuff on the bottom. That gives us 0.369 moles of aluminum oxide. All right, now pause the video and try problem number 8 on your own. Okay, let's see how you did. We start with 65.7 moles of aluminum oxide. Step 1, which is convert to moles, not necessary. Our given is already in moles. We go straight to step 2. We're going to convert from moles of aluminum oxide to moles of oxygen because that's what they were asking about. Now, they wanted to know how many liters of oxygen, so we actually do need step 3 here. So we're going to have the 1 mole to 22.4 liter conversion factor at the end. Multiply across the top, divide by what's on the bottom. Your final answer will be 2,210 liters of oxygen. Okay, our next problem. How many grams of oxygen would be produced from 641 grams of aluminum oxide? Our given is 641 grams. Now, convert to moles for step one? Yes, we actually need to. So we're going to use the 1 mole to X grams conversion factor. We looked up on our periodic table, aluminum oxide is 101.961. Then we need step 2, mole to mole ratio, moles of aluminum oxide on bottom, moles of oxygen on top. And they actually asked for grams, so we do need step 3. This problem has all 3 steps. That will be this one at the end. 1 mole of oxygen has this many grams. So you're going to multiply everything across the top, divide by what's on the bottom, and our final answer is 302 grams of oxygen. So take a minute and let's do problem 10 on our own and see how you do. Okay, let's check. We start with 50 grams of aluminum. So step 1, convert to moles, is necessary. 1 mole, 26.982 grams of aluminum. That's done. Step 2, convert from moles of the given, which was aluminum, to moles of the unknown they're asking about. Fill in the numbers. Step 2 is done. Step 3, they wanted to know how many liters of oxygen. So we have to convert to the unit they wanted. 1 mole equals 22.4 liters. Now we just do the math. Multiply across the top, divide by what's on the bottom. Your answer will be 31.1 liters of oxygen. Okay, another mixed practice with all 3 steps. They want to know how many grams of aluminum oxide would be needed to produce 1,258 grams of aluminum. So our given is 1,258 grams of aluminum. So step 1, convert to moles. That is necessary. 1 mole of aluminum has 26.982 grams. Step 1 is done. Step 2, moles of aluminum need to be converted to moles of aluminum oxide. So we fill in just like this. Moles of aluminum on bottom, the 4 goes here. Moles of aluminum oxide on top, the 2 would go here. Now they asked for grams of aluminum oxide. So we need 1 mole of aluminum oxide equals 101.961 grams. Now we're going to multiply everything across the top, divide by what's on the bottom. Our answer will be 2,377 grams of aluminum oxide. Okay, let's practice that one again and see if y'all have got it. Okay, let's check your work. We start with 7.50 times 10 to the 22nd atoms of aluminum. So step 1 is necessary. We have to convert to moles. Once we convert to moles, we go to our mole to mole ratio. Moles of aluminum on bottom, moles of our unknown on top. And they wanted to know grams of oxygen, so we need this last step 3. 1 mole of oxygen has 31.998 grams of oxygen. We do the math. Our answer is 2.99 grams of oxygen. Okay, number 13. If 12.5 grams of aluminum oxide react to produce aluminum, how many atoms of aluminum are actually produced? Take a minute to try to do this one on your own. Okay, let's check your work. So we start with 12.5 grams of aluminum oxide. We got to convert that to moles first because it wasn't in moles yet. So 1 mole is this many grams of aluminum oxide. That's step 1. Step 2, which we always need step 2, convert the given, moles of aluminum oxide, to the unknown, moles of aluminum. We filled in the numbers from the equation up here. Finally, they wanted to know how many atoms of aluminum were produced. So we do need step 3. 1 mole of aluminum has 6.02 times 10 to the 23rd atoms of aluminum. Do the math, your answer comes out to be this. Okay, so problem 14. How many grams of copper nitrate will be produced if 0.750 moles of copper are available? Try this one on your own. Okay, we're not going to show you all the work. That should be your final answer. Now, problem 15. How many liters of nitric oxide can be produced from 50.6 grams of copper? Starting point is 50.6 grams of copper. That's not in moles, so we got to convert to moles. Then we need step 2, our mole to mole ratio. Step 3, convert to liters. 1 mole of nitric oxide gives us 22.4 liters. When we do the math, we get 11.9 liters of nitric oxide. Try number 16 on your own. Number 16 was easy. It gave you moles and asked for moles. So almost a trick question. 8.0 moles of H2O. Don't need to convert that to moles for step 1 because it's already there. Step 2, mole to mole ratio. Moles of H2O on bottom, moles of nitric acid on top. Do the math, you get 16 moles of HNO3, or nitric acid. Okay, that's it for today's lesson. So work on the corresponding pages in your practice packet, and we'll see you on the next video.